Hi, welcome to part 3 of our lecture on the solar system. In this part of the lecture, we will be exploring the outer solar system. The outer solar system consists of 4 major planets. These are the gas giant worlds, Jupiter, Saturn, Uranus, and Neptune. We'll also be looking at a different and new classification of planet called the Dwarf Planets, which includes Pluto. Let's start with the king of the planets, Jupiter. Jupiter is the largest and most massive planet in the solar system. It's over 300 times the Earth's mass. Jupiter has distinct horizontal stripes, which are cloud belts and bands. And they're seen in photographs like this, and they can be seen through even small telescopes from your backyard. One of the interesting features on Jupiter is the Great Red Spot, which is shown here. This is a giant rotating storm system that's twice the size of Earth. One of the other interesting things about Jupiter is that it has 79 moons. Let's take a look at Jupiter's interior structure. Jupiter is a gas giant planet, meaning that it consists mostly of the gases hydrogen and helium. The composition of Jupiter's atmosphere is similar to the Sun, and there's a reason for this. Both formed from the same solar nebula gas. So if we were to slice through Jupiter, we would see that way inside of Jupiter, it's thought to have a heavy element core, and you can see this core of Jupiter is actually larger than the Earth. And this core actually attracted all of the gas that remains in Jupiter's atmosphere. But the majority of the volume of Jupiter is mostly hydrogen. And as we go down farther and farther into the planet, the gas becomes more and more dense and actually becomes liquid. The cloud belts on Jupiter are those alternating dark and light belts and zones, and the dark belts and the bright zones are caused by differences in pressure. So high pressure pushes the clouds up to create a brighter zone that reflects more sunlight, and lower pressure pushes the belts down and creates the darker effect where less sunlight is reflecting off. This is a neat time-lapse video of Jupiter's cloud belts showing how dynamic they are. You can see the swirling and the motion of the different belts and zones within the cloud belts of Jupiter. And also you can see that here's the Great Red Spot, which is like, again, it's like a giant hurricane storm on the surface of Jupiter that's twice the size of Earth. And you can see the swirling clouds inside that. Also, occasionally you'll see these dark spots appear in the video. Those are some of the moons of Jupiter that get caught on this time-lapse video. Remember that all of the outer planets, the Jovian gas giant planets, have rings, not just Saturn. And they're sometimes very difficult to see. So this is an interesting picture showing Jupiter's ring. This is taken from basically behind Jupiter, looking towards the sun. So this is the back side of Jupiter that's not illuminated by the sun. And you can see that it does have a ring system here. These rings are composed of microscopic dust particles of rocky material. And this photograph was taken not from Earth. We can never see this from the Earth because Jupiter is much farther from the sun than the Earth is. And in order to get behind the planet, we sent spacecraft there, and this is from the Galileo spacecraft. As mentioned earlier, Jupiter has 79 moons. The 4 largest moons of Jupiter were discovered by Galileo 400 years ago, and so today we still call these the Galilean moons. Their names are Io, Europa, Ganymede, and Callisto. The rest of the moons are much smaller, minor moons, and most of those were probably captured by Jupiter's enormous gravity. So they're more like asteroids that were captured in the early part of Jupiter's formation. One of the interesting things about Jupiter's moon Europa is that we're almost certain that it has liquid water underneath its ice crust. So this is showing the icy surface of Europa, and underneath there's thought to be a liquid ocean. So one of the future missions, hopefully, will be to send a probe to Europa and actually have it drill through the ice and release a submersible robotic submarine that can explore underneath the surface of this ice and explore the ocean. And one hope is that there is geothermal activity on the the inside of the moon Europa that would produce thermal vents similar to what we see on Earth. These thermal vents in deep parts of Earth's ocean create enough energy and heat for life to actually exist. And so the big question is, could there be life on this frozen moon of Jupiter? Another of Jupiter's moons is called Io, and it's the one that's closest to Jupiter. Because Io is so close to the planet Jupiter, it gets squeezed and stretched due to tidal forces. And this creates a lot of volcanic activity on Io. Io has over 100 active volcanoes. In fact, in this image here, you can actually see a plume from one of these volcanoes shooting out into space. And these other images here are showing lava flows on the surface of Io. So Io is a very geologically active world. Let's now move on to the next planet out from Jupiter, and that is Saturn, the beautiful gem of our solar system. Saturn has 62 known moons, and like Jupiter, it's mainly composed of gas, of hydrogen and helium, and it has a liquid hydrogen core. So this is an image of Saturn taken from an orbiting spacecraft. And it just shows the beauty of the rings, and you can also see the cloud belt structure on the planet itself. So Saturn is known, of course, for its rings. And it turns out that Saturn's rings are actually made up of tens of thousands of individual ringlets. And you can see those in tremendous detail here, seen from the Cassini spacecraft, which was sent there to explore Saturn. So what are these rings made of? Well, they're made mostly of water ice. So if an astronaut were to actually float around inside the rings, he or she would be experiencing something like this, with ice particles of various sizes, and each one of these particles is, in a sense, like a moon. It's orbiting around the planet, and they're all co-orbiting together to form the ring systems. Saturn, as I mentioned, has over 60 moons, but by far its most interesting moon is the moon Titan. Titan is in some ways Earth-like in that it has a dense nitrogen atmosphere just like the Earth, and Titan also has lakes and rivers. However, the difference is these lakes are not filled with liquid water. They're filled with liquid ethane and methane. Now, on Earth, ethane and methane are gases, but because it's so cold on the surface of Titan, these gases are actually in a liquid state. So Titan has a sort of a cycle of water similar to our water cycle on Earth, where water evaporates, forms clouds, and then precipitates back down to the Earth as rain to fill up lakes and rivers. The same thing is happening on Titan, but it's not water, it's ethane and methane. We actually dropped a probe down onto Titan that came from the Cassini spacecraft back in 2005. This is an artist's rendition of what it looked like, and this probe landed successfully on the surface of Titan and returned images. This is one, and these what look like rocks on the surface of Titan are actually frozen water ice. So these are like giant ice cubes on the surface. Let's now leave Saturn and travel outward to the twin gas giant worlds of Neptune and Uranus. So Uranus and Neptune are very similar in size and in composition. They are, again, gas giant planets. Notice their size here compared to Earth. They dwarf our Earth. They have a blue-green color due to methane in their atmosphere. So their atmosphere, again, is mostly hydrogen and helium, but the presence of methane tends to filter out certain colors and reflect the blue, kind of blue-green light. Uranus and Neptune can be seen through small amateur telescopes, and they appear as a blue-green small circle in the telescope field, as shown in these pictures down here. Uranus and Neptune also have ring systems, just like Jupiter and Saturn do. And again, these rings are not quite as obvious and beautiful as Saturn's rings, but they can be seen by using special imaging techniques. This is a Hubble Space Telescope image of Uranus, and you can see its ring system here. And this is an image taken from the Voyager spacecraft back in probably the 1970s. Looking towards the sun, this is where the planet Neptune would be, and you can see these rings are backlit by the sunlight scattering forward through the ring materials. The internal structures of Uranus and Neptune are similar. They both have very thick atmospheres consisting of hydrogen, helium, and methane. And then underneath that, there are mantles of water. Basically, this would be frozen water, ammonia, and methane. And then they have a heavy element core made most likely of rocks and ices. Uranus and Neptune have about 40 moons between the two of them. And these moons are, now that we're leaving the inner solar system and we're out in the far reaches of our solar system where the temperatures are much colder, the moons are different composition than, for example, our own moon, which is rock. The moons in the outer solar system have ice crusts that cover rocky cores. So the surfaces of these moons, these are 5 major moons of Uranus, we're basically looking at ice on the surface there. This is another picture. This is a neat image here taken in infrared. This is Uranus here. You can see its rings show up very nicely in infrared. And these are its 5 major moons shown here, which are all orbiting around Uranus. These are a couple of Neptune's moons. This is Triton here and Proteus here. All of these images here were taken by the Voyager spacecraft that went on a reconnaissance mission to look at these outer planets of the solar system. Let's now travel out to the planet Pluto. And when I say planet, I have to be careful there because Pluto actually is not classified as a major planet anymore. We'll talk about that shortly. Pluto is very different from the other planets that we have studied up till now. Pluto is not a terrestrial planet with a rocky crust, and it's not a Jovian gas giant planet like the outer planets of the solar system. Pluto is an ice dwarf. It's made mostly of ice. These are amazing photographs, images taken of Pluto and its moon Charon that were taken by the New Horizons spacecraft that arrived at Pluto in the year 2015. And we can see for the first time what the surface of this outer world of the solar system looks like. So Pluto is smaller than any of the other planets. It's even smaller than Earth's moon. So a new classification of planet here is called a dwarf planet, and Pluto is one of the members of these dwarf planets of our solar system. Pluto also has an orbit that is tilted out of the plane of our solar system, so it's not like the other 8 planets in that sense either. Its orbit is also highly elliptical compared to the nearly circular orbits of the other planets. So in summary, Pluto is very different, and it deserves a different classification as the other planets of our solar system. One of the interesting discoveries by the New Horizons spacecraft, when it flew by Pluto a few years ago, was just seeing for the first time the surface and the details of what Pluto actually looks like, because up until then, it was really a mystery of what Pluto would be. One of the interesting findings was the possible presence of what are called cryovolcanoes, or ice volcanoes. And on Earth, if we think of a volcano, what's happening is liquid rock, which is lava, is coming from underneath the ground and bubbling up through the volcano and coming out the top. On Pluto, it's a whole different geology. So it's a volcano that erupts liquid water, because the water is normally frozen underneath the surface of Pluto. But in this cryovolcano, there's enough thermal energy there to liquefy this water, and not just water, but ammonia or methane. So the lava, what we call lava on Pluto, is actually water, ammonia, and methane. And then these materials freeze after eruption. So this is an image of I'm not sure if this is an active or a dormant ice volcano on Pluto. Pluto is not the only dwarf planet in our solar system. In fact, we have no idea how many dwarf planets there may be in our solar system. As of right now, there are 5 confirmed dwarf planets in our solar system, Pluto being the most famous and popular of those. Another one is Eris, which was discovered and is actually larger than Pluto, but it's farther out in the solar system. One that we've known about for a while is actually an asteroid, and this is the asteroid Ceres. It's the largest asteroid. It's about 600 miles in diameter, and because of its large size, it actually formed as a sphere, like a planet would. A couple other dwarf planets are Makemake and Haumea. So where do the majority of these dwarf planets come from? Well, they reside in an outer region of the solar system called the Kuiper Belt. So the Kuiper Belt is a region of the solar system beyond the orbit of Neptune that contains thousands of icy planetesimals. Planetesimals meaning these are chunks of material not large enough to be a planet necessarily. However, within the Kuiper Belt, there are dwarf planets, including Pluto, Eris, and there may be many, many more. We have no idea of how many there are. Are there 10? Are there 100? There could be 1,000 more dwarf planets waiting to be discovered here in our own solar system. So where is this Kuiper Belt? Well, here's a model of our solar system. This is the Sun in the center, and then the inner planets, including Earth and Mercury, Venus, and Mars, are not shown here because they are very close to the Sun. Here is this orbit here is Jupiter. So these are the outer planets of the solar system. Here's Saturn's orbit, here's Uranus's orbit, and notice Neptune is right here. So Neptune's orbit sort of marks the beginning of the Kuiper Belt. And Pluto, remember here's Pluto out here. Pluto is part of this Kuiper Belt, and this Kuiper Belt is full of debris left over from the formation of our solar system. And we really don't know much about it. The New Horizons spacecraft is exploring it right now, but much more will be learned over the next years and decades about this remote region of our solar system. Our last slide in this part of the video, let's take a virtual journey out into the Kuiper Belt, and this is a very interesting image taken from the New Horizons spacecraft, where it did a rendezvous with a Kuiper Belt object, which they've named Ultima Thule. And it is a what they call a contact binary, meaning it's 2 different planetesimals or chunks that are basically connected together, probably by their weak gravity. And what is this thing made of? Well, we think it's water, ice, rock, methane, and traces of organic molecules. These things are roughly 19 kilometers in diameter and 14 kilometers in diameter. So these are objects that are the size of roughly the size of a city. The Kuiper Belt is populated with objects like this, and it's basically ripe for exploration. There's so much we still don't know about this outer region of our solar system. So that concludes our virtual tour of the outer solar system. We'll continue this tour in the next part of this video.